In this video, let us look at the Griffith's criterion for brittle fracture. Okay. Consider a body like this. And okay, this is your body. Okay, suppose it has got a crack in the middle, right? So its size be 2a. It is at this surface, it extends up to this other surface. So its width is 2a, and this width, okay, this is b. Okay. So we need to examine the driving force for this crack growth, driving force for crack propagation, crack propagation. So the driving force is, you can see that any system will become remain stable if its energy decreases. Okay, so you can see that the driving force is actually the decrease in mechanical energy, decrease in mechanical energy due to strain energy, strain energy and external work done. Work done. So here the stress is applied, stress is tensile, sigma here, and here it is sigma. Okay. Okay, so the mechanical energy is, let us compare the mechanical energy with uncracked body and cracked body. So U0 is the mechanical energy of uncracked plate, uncracked plate. So this is the plate, and UA is the mechanical energy of the cracked plate. So this is equal to mechanical energy of cracked plate, cracked plate. So delta U is equal to UA minus U0. So see, this is not derived here, but it can be derived in terms of the applied tensile stress, that is equal to minus pi sigma square A square B by E. Okay, here this sigma is the tensile stress, tensile stress, and A is the crack size, A is the crack size, B is the width, okay, width of the plate, E is the Young's modulus, okay, Young's modulus, right? So these are the important. Okay. So, so this is the reduction in mechanical energy. You can see that with a when there is a crack, when you um, when there is a crack, mechanical energy decreases. So we should ask a question now. That is, if there is a reduction in if there is a reduction in mechanical energy of system, okay, you can see that there is a reduction in mechanical energy of system. Why does not a crack propagate? Why does not a crack propagate even at a very small size? Small stress. Okay, it is no stress. See, since the mechanical energy of the system is coming down, that means if you apply a stress, however small it may be, this crack should propagate. That means energy of the system is coming down. But to answer this, we need to understand one more thing. If you consider this body, if you consider this body, so that means it has got a crack. So with the introduction of propagation of crack, okay, here with introduction or propagation of crack or propagation crack, two free surfaces are created. So that is the another thing you need to know. Two free surfaces are created, and this surface has got its surface energy associated with that. So let gamma be the surface energy, that is the surface energy per unit area, per unit area of the fractured surface, of the fractured surface. Okay. So that means let us find the change in the surface energy here. So that means since new two surfaces are created, the surface energy increases. So surface change in surface energy is equal to 2 into 2AB. This is the surface area into gamma, that is surface energy per unit area. Since two surfaces are created, we are multiplying by 2. So that means in addition to the reduction in mechanical energy, you have an increase in surface energy. Okay? So that we need to understand is that energy, change in energy due to crack propagation, due to crack propagation is delta UR is equal to delta UM plus delta US. Okay, so you need to consider both mechanical energy and surface energy. So change in mechanical energy is minus pi sigma square A square V by E plus 4AB gamma. Okay, so you need to take into account these two energies. Now let us try to depict these uh, in a diagram. So here it shows delta U, and here you have the x-axis, you have the track size. Okay, y-axis you have change in energy. So, so this straight line will give you the change in surface energy. Delta US is equal to 2AB gamma. And this curve will give you the change in mechanical energy delta UM is equal to minus pi sigma square A square B by E. Right? So the total energy change is equal to, so it will be like this. So the total energy change is equal to minus, so see, let us write here T delta U total. So this is delta U total. Right? So you can see that, see, uh, the total energy increases up to a crack size that is AC. See, you can see that it increases up to here total energy. After that, this energy comes down. Okay, and this AC is called the critical crack size. So that means if the crack size is greater than critical crack size, you can see that its total energy of the system comes down or the crack will propagate. Before that, if the here if the crack size is less than AC, critical crack size, then the as crack size increases, only the total energy increases. That means so the crack will not propagate. So that is what you mean by this critical crack size. Okay, so let us note down that. So that is cracks with a uh, with A less than critical crack size will not grow, and cracks with A greater than AC will grow because surface total energy is gradually increasing, uh, is decreasing. So how will you find the critical crack size? You find the critical crack size for fracture. For fracture. That is, that means you know that delta U T total change in energy is equal to minus pi square sigma A square B by E plus it is 4AB. Okay, you need to, if you want to find the critical crack size, you need to differentiate it. That is delta UT by dA. And if so, we need to find the crack size when this becomes zero. So this is equal to when you differentiate it, you will get it is minus 2 pi square sigma A B by E plus 4B gamma. This is equal to 0. So that means from here you can find that this A is equal to 4BE gamma by 2 pi square sigma B. So that is 2E gamma by pi square sigma. So this is the critical crack size. That means if crack size is greater than AC, then crack will propagate. Otherwise, crack will not propagate. So So we have got this expression that is AC, critical crack size is equal to 2E gamma by pi square sigma. So now let us draw that in a graph. Okay. In x-axis you have sigma and in y-axis you have the critical crack size AC. So how the critical crack size varies with respect to sigma. That means you can see that if you take Young's modulus, gamma, etc. constant, that means AC is proportional to 1 by sigma. Okay, so you can see you will get a hyperbolic curve here. Let us draw that. So the curve will look like this. Okay, right. So that means if you if you want to find the critical size for a particular tensile stress, particular applied sigma, then you can find AC corresponding to that. Okay, AC corresponding to that sigma. Right? That means, so this is the corresponding crack size. Okay. So for this sigma, so if the crack size here, if it is greater than AC, so it will fail, and if it is less than AC, it is safe. Okay, so that means if you go up, so this is not safe, and here it is safe. If the crack size is less than that, it is safe. This is how you find the crack size for a particular applied stress. So let us note down that this is the critical crack size for a given stress. Now, let us look at the critical crack size for fracture for sorry, we will find stress, critical stress for fracture for a given crack size. So you're given a crack size. So what can be the maximum stress that you can apply? Again, for this, you will draw a curve that is between uh, the crack size and the tensile stress. So you will get a curve like this. Okay, you will get a curve like this. So that means here you are given a particular uh, crack size AC. So that means for this, the maximum tensile stress you can apply is sigma. So if it is, see, if you look at this region, that is not safe. So if you look at it, stress above this one, this is not safe. So here, if you look, this is a safe region. Okay, this is how you find. So that means, see, our equation is given as AC is equal to 2E gamma by pi sigma square. So that means you can see that sigma fracture stress, if you look at it, is 2E gamma by pi AC root. Okay, that means this sigma will go here, right? So this is the fracture stress for a given crack size. If sigma is greater than this fracture stress, crack will propagate. Okay, crack will propagate. So that is what you mean by